In this video, we're going to talk about aggressive scanning and bug bounty and how you can avoid it. We'll start by defining what aggressive scanning is, and then we'll look at the reasons that you should avoid it, the steps that you can take to avoid it, and then how we can configure some common tools to make sure we stay within the defined limit. So what is aggressive scanning? Is it 1,000 requests a second? Is it 100 requests a second? Is it 10 requests a second? The answer is there's no fixed value. The term aggressive could be applied to any scan that falls outside of the acceptable limit. The next question then is, what is acceptable? It's whatever the bug bounty program says it is. Researchers implicitly agree to the program terms when they start hunting, so if you don't like the defined limit, pick another program. Just like if you find the scope of a program to be too restrictive or the bounty table to be too low, you would move on to another. It's the exact same when it comes to these requirements. If a program says don't send more than 5 requests a second, and you're not happy with that, move on to the next program. Okay, let's take a look at some examples then. I'm over on Intigriti.com at the moment. I'm logged into my account and I'm looking at the public programs. So I'm going to select Ada Health first of all. And we want to scroll down. Here's our bounty table. We want to know how much we're going to get paid, but we also want to know what are the rules of engagement. And here it says that if we're using any automated tools, we have a limit of 5 requests per second. So if we go over that, we'll be breaking the rules of engagement. It's also worth noting that for this program, we would also need to register with our Intigriti.me email address. And this is basically just an alias so that whenever you sign up for an account on Ada Health, it will send an email to your Intigriti.me, which is just your username at Intigriti.me. That email will be forwarded to your personal email, which is linked to your Intigriti account. So that's worth bearing in mind. In this case, you also need to add a request header so that every request that comes through, Ada Health will know that you are a legitimate tester and not some malicious actor that they need to investigate. Providing that we stick to these rules, so providing that we stick to these rules of engagement and also that we respect the code of conduct, the terms and conditions, the scope of the program, and that we don't publicly disclose anything, that means that we're granted safe harbor. So we're basically immune from legal prosecution, providing that we adhere to all of these requirements. Here's another example. We have the data count program, which once again has a maximum limit of 5 requests per second, and you also need the Intigriti.me email address, but you don't need to set a request header in this case. Here's the DHL vulnerability disclosure program, and this one has a maximum of 2 requests per second, so this is the lowest yet, and it also requires the Intigriti.me email address and a request header with our username in it. Next up, we have Intel, and this one has NA for the automated tooling, so it doesn't actually set a limit, nor does it have an Intigriti.me email requirement or a request header or user agent. So you might want to just do a Control and F on a page whenever you see this, just in case it says somewhere else that there is a limit. But if you have a look through this program, you'll see that the reason is it's focused on not like web assets that you would typically brute force, but instead hardware. So there aren't actually any domains provided here, which is the reason they've put NA for the automated tooling section. The final example we're going to look at is Ninja Kiwi Games, and they have a maximum of 10 requests per second, which is double the max we've seen so far, which has been 5 requests per second. And in this case, we don't have any other requirements regarding our email address or the request header, but of course, we do still need to adhere to the code of conduct and the terms and conditions, respect the scope, and not disclose any sensitive information. Alright, we've looked at what some of the limits are. Let's go and see how tools respond by default. So I've opened up a Portswigger lab here. I just picked one at random, and I'm going to test out gobuster first of all, which is a popular tool for directory busting. So let us, first of all, let us just make a word list. So I'm going to create a word list. I'm going to do head-n 1,000. So take the first 1,000 words from, and then I'll do user share word list and dir and then common. Save that to words.txt, and then we can do a word count on that, make sure it looks okay. It does, we've got 1,000 words in there. So I'm going to do gobuster, directory mode, we'll give it that URL of the Portswigger lab, and then we'll give it the word list as well. And let's try and run that. So it's running, it doesn't actually give us any information showing what the time is on it. So I'm going to cancel that. What you might want to do is try and do a -h and then look for look for grep-i and then time, or maybe you want to try and just find like a debug mode or put it in verbose or something like that. I don't think gobuster actually has much in the way of us checking this. So another thing we could do, we could potentially proxy our traffic through Burp Suite or something and have a look at it in there. We could have a look at Wireshark and see how fast the requests are going through. Or if we just want a really rough idea, we could actually just use the time function. So if I do now time before the command, it's going to run those 1000 requests, and at the end, we'll just get to find out how long it took from the start of us running the command to the command finishing. It took around 20 seconds for 1000 requests, so that is about 50 requests a second. So that's 10 times the limit that we were looking for on our first two programs, the 5 per second. It's 25 times the next one, and it's still 5 times the most liberal program that we looked at, which was Ninja Kiwi Games at 10 requests per second. Let's go and have a look at another tool as well. So I'm going to go and try and log into our account. I'll just put in an incorrect username and password, and I'm going to go and grab the request from Burp Suite and take a copy of it. I'm going to go and save this into a file called new.request. We're going to use ffuf this time, and we're just trying to brute force the login credentials. So I'm going to replace the password with a capital fuzz. And I actually have an alias set up for this. If I do type-a ffuf-request, you see I have a bit of a function which by default will just take ffuf-request and it'll read in a new request file, and then it'll run through this default word list, which is files and directories word list. But in this case, I want to run through passwords. So I'm going to do a new word list. I'll say ffuf request, and then I'll do user share seclist passwords probable top 1575. Start running, and we start getting a lot of responses, and the reason being we need to try and filter out either the size or maybe the response itself. If I go back to Burp Suite, you'll see that the response we got back said invalid username or password. So what I'm going to do is say -fr to filter out regex, and then I'm going to put in here invalid. So any requests that have invalid in the response won't come back. And notice that it's actually showing us 70, 80 requests per second as it goes, unlike gobuster, which didn't give us any indication of how fast it was running. And there we go, we leave it to finish. It comes back and says that it took 23 seconds to run through 1575 passwords, which is 60 requests per second. So we have defined what aggressive scanning is. We've looked at some example programs and what kind of values are commonly set for the max requests per second. And we've had a look at a couple of tools to see by default how many requests are typically sent per second. Now let's talk about why we should avoid aggressive scanning. So there are two key categories here. One is the impact to organizations and the other is the impact to researchers. Impact to organizations. One is performance. So if you hammer targets the traffic, that can obviously have serious impact on the performance. And in a worst case scenario, the impact can be so severe that it leads to downtime, which is the worst nightmare for most companies. Finally, there's noise. So defenders are monitoring for threats, and this becomes very difficult when you have an endless flood of attacks, especially if that's coming from many users. Remember, behind every bug bounty program, there is a program manager who's constantly being forced to justify the benefits of bug bounty versus the negatives, and one of those negatives is disruption. If you're a bug bounty program manager and you're constantly getting all this noise and you have the blue team saying, we can't deal with all these alerts, you have other teams saying the performance of the website is too slow, this is affecting our customers, it's going to be very hard for that program manager to justify why they should keep running the bug bounty program rather than just going back to a pen test every few months. And next is the impact for researchers. And this is really consequences for researchers because according to the code of conduct, you must adhere to the program requirements, to the scope, to the rules of engagement and all that. So if you start sending 50 requests per second when the limit is 5, what's going to happen is you'll get contacted by support from Travis or Joe with a warning to say you're breaching the scanning rules, and if you continue to do this, there will be further sanctions. So that could lead to reports being invalidated, and if it persists, you may be removed from the program or even suspended from the platform. Now that we know the reasons to avoid aggressive scanning, let's talk about how you can actually do it. The first thing is to study scope requirements carefully. So make sure you read through those rules of engagement and you're clear how many requests per second are allowed, but also the other requirements. So whether you need that Intigriti.me email, whether you need to set a specific request header, and just very important to make sure that you are very aware of what assets are in scope and out of scope for testing. Secondly, you should configure your tools correctly. So most tools will use the maximum request by default, and you need to check the documentation and find out how to limit it. We'll look at some examples shortly. You can make your life a lot easier by using grep in this case. So for most tools, if you just use the pipe and then pipe the output of the help menu to grep and look for some common keywords like rate or limit, and if they're not finding anything, you can look for like sec or time or request, then you'll probably quickly find the option that you need to configure. You should also bear in mind that the limit is not per tool, it's overall. So you can't just look at a program that says maximum 5 requests per second and then think, okay, well, I'll set burp to 5 requests per second, then I'll set ffuf to 5 requests per second, and I'll set sqlmap to 5 requests per second. That's going to be more than 5 requests per second overall. However, the limit is per program. So if you're only allowed 5 requests per second and you don't like wasting bandwidth, then of course you can be running scans on multiple targets from different programs in order to maximize efficiency. Let's take a look at some more examples then. So I have that command that we just looked at here, which is just the tool with -h, and then we're going to pipe it to grep, case insensitive, and then we're going to look for some of these common keywords. And if we do that, we'll see that we have a rate function. So this is the rate of requests per second, and by default it's 0, so it's unlimited. So that means we could try and do the command that we did earlier. In fact, I think I've still got this here. Yep. We can do this one, and then we can also say we want to set the rate to, and what were we allowed? We were allowed 5 requests per second. So I'll set that to 5. We'll run it again, and you can see that it's just staying at 5 requests per second. You can see the progress is very slowly moving along. And that's it. We've correctly configured ffuf in order to stay within the allowed limit for the program. Awesome. Let's do the same then with gobuster. So I'm going to just replace gobuster here. And in this case, we've got a delay. So this one isn't saying how many requests per second will we allow. It's saying what delay do we want to insert in between each request. So in this case, if we want 5 requests per second, we'd want there to be a 0.2 delay in between each. And that's actually in milliseconds, so it wouldn't be a 0.2 delay, it would be a 200 delay. So I think we've still got our gobuster command here as well. Here's the gobuster command. We could do it with the time option, but it doesn't really matter. And what was the option that we needed to set? -- delay and 200 milliseconds. Okay. We actually need to put in ms at the end, so maybe it takes seconds as well. But there we go, we put in 200 ms. And now we can see that it's running a lot slower than it was previously. Okay, that finished in around 35 seconds. It would have seemed a lot faster to you because I sped up the video, but that's not right, is it? Because if we were doing 5 requests per second, there's 1,000 requests, we would expect it to take around 200 seconds. So this isn't right, and if we would have just run this against a bug bounty target, we would have exceeded our limit. I think this is around 25 or 30 requests per second. So what's the reason? Because we just set up that delay, and if we go and have a look at the documentation again, it actually says here, time each thread waits between requests. So this is very important. It's not saying how much time between each request, it's saying how much time between each request per thread. And I don't know what the default is, how many threads are there, so I'm going to do grep, and then we'll just grep for thread, and we'll see the default is 10. So we're waiting 200 milliseconds, but it's running 10 threads at a time. So obviously that is not good. Let's change this again, and let's say we want to run it again, but we want to set the -t to be 1, because we'll just do 1 thread. Optionally, we could also do like 5 threads and then just change our delays accordingly, but I'm just going to set it to 1 for now. We'll start running that, and you can already see just by watching it that it's going through at a far more reasonable pace. It looks like it's actually going through slower, so it's doing less than 5 requests per second, I believe, but you could play around with that. You're only going to get in trouble if you send more than the limit, so don't worry too much if it's not as efficient as it could be whenever you first start the scan. You can always fine-tune it. Okay, let's look at another tool then. Let's try and have a look at sqlmap. That's another very popular tool. So we'll do sqlmap with grepping for the same stuff. And notice that we don't get back anything related to the time this time. So you could go and add some more words here. Maybe we add in seconds or sec or time, things like that. Actually, the reason for sqlmap, if we do sqlmap-h, it will come up and say, if you want the full list, do -hh. So let's do this again and just do -hh. This time we get a lot more options, and one of them is the delay, and it's the delay in seconds in between each HTTP request. I'm not sure if this one has threads as well, so we could test this one out. In fact, I think we'll just do this with our existing request. I'll do sqlmap -r, and then we pass in our new request, and then --batch because I don't want it to ask me any questions. And then what was the time? Delay is, let's say 0.2 and see how this looks. I think it comes up with a time at the end of this anyway, so let's see. It says the web server responded with a 400 error. Still up and running anyway. Okay, it didn't come back and tell us how many requests were sent, which isn't great. I guess we could proxy this as well. Let me do rep-i proxy. So you could actually just send this. Oh no, I didn't mean, I meant to open up the help menu. Okay, so yeah, you can do like --proxy equals http 127.0.0.1. Burp is on 8080 by default. Just want to see, does this start going through? Burp suite, and it does. Notice we get all our requests here. So we're getting a 500. It says it's not accessible over HTTP. Okay, so we just need to go and update the protocol for the proxy in the sqlmap command, but it's not really important for this case. But there's another way that we could go and have a look at how long these requests are taking or how many are going through per second. Oh, and finally, I guess, is burp. While we're on the burp application, let's see what we could do here. So let's say, for example, we have a crawl which is running at the moment. We have these tasks, and we can actually go into the settings here and define a resource pool. And this is pretty cool because you can create multiple resource pools. So it means that if you test in multiple targets, you could have a different pool set up for each one based on how many requests per second are allowed. Or if you just want to have some scan that's taking precedence that you're using more of your bandwidth on, then you could configure it that way. So maybe you create it here and you would put in like the program name, and then you would say, what's the maximum concurrent request? So you could say, if we want 5 requests per second, you could say maximum is 1, and then the delay between requests is 200. Or you could say that we want 5 maximum requests, and then we could just divide this. So whichever is your preference, I guess it makes sense to have concurrent requests running as long as you make sure you adjust the delay accordingly. So in this case, it would be 5 concurrent requests and then a 1 second delay in between each set of 5 requests. So just to summarize, aggressive scanning impacts both companies and researchers. It's important for you to understand your responsibilities as a bug bounty hunter. So how many requests per second are you allowed to send? And are your tools behaving as you would expect? So review the documentation, test it locally, make sure everything's working as you expect, and make sure you follow the other requirements. So use your intigriti.me alias or your HTTP headers where needed. And this means we can identify any issues as they arise. Good luck. I hope you find many bounties. And if you want a quick summary of the rate limiting setup and also a video on how to do it on nuclei, then there is an article on intigriti.com, which I'll show now and I'll link in the description. And you can have a look at that. That also covers how to configure some of the tools we've looked at today, like ffuf and burp. Anyway, I hope you've enjoyed this video. If you have any questions or comments, leave them down below. Thanks.